It's very well known that global warming resulting from the emission of greenhouse gases has received widespread attention with important international actions from governments and industries. Carbon capture and storage are critical and emerging technologies suitable to achieve the emission reduction objectives. And all of this mainly taking into account that Europe produces around 4,000 millions of tons of CO2 by year. Of course, zero emissions are not possible, but we can reduce them. In this context, Gramofon Project arises to introduce new technologies to capture CO2 from post-combustion gas industrial sources, introducing new high-absorbing materials such as metal organic frameworks and graphene oxide, and also introducing new technologies to reduce energy requirements during the desorption process, like microwave. Finally, the main objective of Gramofon Project is to reduce the emissions of CO2 and to reduce the cost of the captured CO2 in terms of technological investments, maintenance, safety, and of course energy requirements.
We are developing a new adsorption strategy technology to reduce the energy consumption to capture CO2 emissions. For this, we combine the development of new adsorbents such as metal organic framework type materials with graphene oxide and their regeneration by microwave heating. Indeed, the use of microwave can significantly reduce the heating time and therefore the energy consumption to improve the overall capture process.
The economic assessment of the Gramofon carbon capture process on an industrially relevant scale is part of this project. Power plant, cement plant and a steel plant have been selected as key energy-intensive sectors. The Gramofon process aims for a cost-effective and energy-efficient process, carbon capture process. The current state-of-the-art carbon capture technology is far too expensive. For example, if your technology is not good enough, your price of electricity can easily double.
In Gramofon, we are developing a new generation of porous nanomaterials that can capture CO2 emissions from the industry more efficiently. These hybrid materials comprise metal organic sponges and carbon-based nanomaterials that combine good CO2 absorption capacity and also the ability to easily dissolve using microwave heating.